We're going to wrap up differentiation theory with what's called implicit differentiation. That is the ability to differentiate functions that have more than one variable in them. And this is very common in the universe, that things are functions of much more than one thing. Implicit differentiation allows us to find derivatives of more complex things, some of which are not functions. Here's a circle. As you know, the equation of a circle includes x squared plus y squared equals the radius squared. This is a circle with radius 1. Sure would be nice to know the slope of this circle at any point, even though it's not a function. So we're going to use implicit differentiation to do this. To take the derivative, we take the derivative with respect to x of everything on both sides of the equation. So we're going to take the derivative with respect to x of x squared, y squared, and 1. The derivative with respect to x of x squared is equal to 2x. The derivative with respect to x of y squared is equal to 2y dy dx using the chain rule. Remember, we're taking this with respect to x. The derivative of 1 with respect to x, as you recall from the constant rule, is 0. What we're going to do now is try to get the dy dx on its own on the left-hand side. So we can do that by moving the 2x term to the other side. This is an algebra equation, so we can use algebra to subtract 2x from both sides. And we were left with 2y dy dx equals negative 2x. Using algebra, in an attempt to isolate dy dx, we're going to divide both sides by 2y. So the rate of change with respect to x of any point on that circle is equal to negative 2x over 2y, or we can simplify that, negative x over y. Let's look at another example. Now ideally we'd like to try and solve things for y. In that case it can become a function. This one cannot be solved for y. So we're going to have to use implicit differentiation to find the rate of change of y with respect to x. Again, we're going to take each term using the sum and difference rules and find their derivative with respect to x. The derivative of 2y with respect to x, the derivative of x squared, and the derivative of sine y, all with respect to x. The derivative of 2y with respect to x is not 2, it's 2 dy dx. The derivative of x squared with respect to x is 2x. And the derivative of sine y with respect to x is equal to cosine y dy dx. Now we're going to try to isolate the dy dx, and we'll do that by moving all the dy dx terms to one side. We do that here by subtracting cosine y dy dx from both sides. The dy dx terms on the left-hand side, we can then factor them out of each of these two terms, and so it's dy dx times 2 minus cosine y equals 2x. Divide by 2 minus cosine y, so we get dy dx equals 2x over 2 minus cosine y. And this is called implicit differentiation. As long as we know the x and y coordinates of any point we're interested in, we can find the rate of change of y with respect to x at that point. Steps in implicit differentiation. First, differentiate both sides with respect to x. Then solve for dy dx, the rate of change for y with respect to x, by isolating the dy dx term or terms on one side. So let's find the equation of the tangent line to the curve x squared minus xy plus y squared equals 7 at the point negative 1, 2. Well, we're going to need the slope. Since we can't solve for y, we're going to have to use the implicit differentiation there to find the slope. So we're going to differentiate each of those terms with respect to x. And note that we've got to differentiate this x times y using the product rule. So it's using the traditional method, it's the first times the derivative of the second plus the second times the derivative of the first. You can use the method that I showed you as well. Derivative of x squared is 2x. The derivative of xy is this combination from the product rule. And the derivative of y squared is 2y dy dx. The derivative of 7 is 0. Go ahead and distribute that negative term. And then we're going to factor out the dy dx from each of the terms that it's in, and move the non-dy dx terms to the other side. When we do that, we get dy dx equals y minus 2x over 2y minus x. We're evaluating this at the point -1, 2. So we're going to put in everywhere we see an x, we're going to put in a -1. Everywhere we see a y, we're going to put in a 2. When we do that, we get a slope of 4/5. Well, now that we know the slope is 4/5 and we know the point is -1, 2, we're going to find the equation of the line that goes through that point with that slope. And we'll put it in point slope form. So it's y minus 2 equals 4/5 times x minus -1 or x plus 1. Once we simplify it and get y by itself, 4/5 x plus 14/5 is the equation of the tangent line. So you've learned how to apply implicit differentiation to find the derivatives of functions that have more than one variable in them.